Hi, today I'm just going to be going over sinusoidal waveforms, so I'll just begin with the basic equation there. I'll just start off with A. So A stands for amplitude. It's basically just the magnitude of the wave, so the peak there, so it's 1 in this case. And then we have F for frequency. Frequency is just basically 2 hertz, so it's just 2 cycles there per second. And then you can also get it by just doing 1 over just 1 cycle, so that's 0.5 seconds in this case, so you get 2 hertz there that way too. And so frequency can also be expressed in radians per sample, so to get that you need the sampling rate. So in this case it's so the sampling rate is basically just how many times you sample something within a second, so in this case it's 1 over 20. And then to get radians per second, it's just how many radians are sampled within a second. So in this case it's 2 pi multiplied by 4, or 2 hertz, sorry, because that's the original frequency. And then you just multiply 4 pi by the sampling rate, and then you get radians per sample. And all radians per sample is how many times you sample a wave within 1 radian of its cycle. So then moving on to phase offset, so it's basically just the position of a given waveform at any point in time. So the phase difference is just the difference in position 2 waves are from each other. So one wave might be either leading or lagging. So in this case, you'd say the blue one is leading the red one. So there's a phase offset of 45 degrees, or 1/4 of a cycle, also pi over 4. So moving on to complex numbers then. So complex numbers are just an easier way to represent a waveform than trigonometric functions. So you just get a kind of compact expression, and it's also easier to add waves together. So in this case, you can either use the rectangular or polar option, but you can only use the polar option to add waves together. So we have X and Y there. So when you add them together, you basically get this.